Hello, it's Hardcore Ninja, and we're back to this SFML side-scroller game engine tutorial series. I hope you guys don't mind the music, and I hope YouTube doesn't take my videos down for having this. I'm streaming this music from internet radio, and it's just like an ambient radio station. I don't know, I like listening to ambient music when I code. It makes me a little bit more creative, so I hope you don't mind listening to it as well. It's weird, it's interesting, it comes from the deepest depths of the internet. I hope you like it. I think sometimes they play some Aphex Twin and stuff on this too, but I know he's not known for like suing people for using his music, and I hope the rest of the artists on this radio station don't try to take my videos down. Just know that I appreciate your music so much, and that I love listening to it when I code. Okay, so last video, we did a lot. We created the side-scroller game engine project. We've dynamically linked all of the SFML libraries, okay, and we created our GitHub repository that allows us to just be complete idiots and save our project and be like, oh, well, no big deal, because I can just like undo that and bada boom, bada bing. Who cares if I screw up? Okay. So that's the point of it. So this is essentially all your standard. I like to just have, this is essentially all your standard C++ libraries are right here under this one header thing. Okay, bada boom, bada bing. Today, we're going to create the game class, okay? And we're gonna get the window rolling. We might be able to do supported keys as well. I might have to look at some cheat sheets from my other programs, so please don't judge me by that. I'm just going to go ahead and put this on release, because with the streaming, release is usually faster than debug, but you're sacrificing some debug information from your compiler when you're on release. But with the streaming and stuff, it's just going to be faster for me to do this. Okay, let's go ahead and get started. So we're going to go to project, we're going to go to add class, and we will call this, game. And this is going to be the most global class that pretty much every other class that we make in the game kind of derives from. All right, so we're going to create the game class. And I like to organize my stuff like this. So I'm going to call that game, and I like to keep the header files that are specific with the classes under their little tiles here. So you see now I'm just working like that, okay? So again, I don't like this Pragma 1 stuff, because if I ever wanted to do this for any other operating system, I would have to go through every single thing and do this, so I'd rather just not deal with that. Do this from the very beginning. Okay, cool. Awesome. Okay. Cool. All right, so this game class, essentially what we're going to do is we're going to initialize the window, and we're going to have kind of a global update function here, and we're going to create a vector of that will allow us to kind of put different states into it. States like the main menu, the settings, etc. We will also initialize maybe the supported keys. We'll also have a render function in here, of course, for rendering stuff. And yeah, so let's just kind of get going. So probably want to create a private part to this. You're going to want to create a public part to this. Go ahead and create a game constructor. Make a virtual game destructor. I like to make all my destructors virtual, just because it doesn't hurt, even if you don't necessarily need the virtual, but it just assures that if you do have inheritance, that everything will be destructed properly, or destroyed properly. So I like to constructor destructor, like that. And then what we're going to do is we'll have some update functions here. So we'll have pretty much, void update We'll also have a void update delta time. All right, so if you don't know about delta time allows you to make your game frame rate independent. And I'll explain that when we get to this concept, but essentially every computer is going to have a different frame rate depending on the graphics card. And essentially what you want to do is you want to grab the time it takes to go through one frame. And on a very fast computer, that number is going to be extremely small. It might be like 0.0000 something. And on a very slow computer, it might be 1 or as high or near or close to 1. So when you use movement, you multiply all your movements by this number. And so your movements have, if your frame rate dependent, you might have a move like 8 pixels per frame. All right, but if you increase that 8 to maybe like 300 and multiply it by delta time, on a very fast computer is going to be multiplied by a very small number and bring it back closer to that 8 pixels per frame feeling that you had. And on a very slow computer, you're going to want to be moving something like 200 something pixels per frame because each frame is so freaking slow. All right, so it's just kind of a multiplier that allows you to make sure that everything is moving by the same rate, regardless of the frame rate. It still may look choppy, the graphics are still going to look like crap, but at least it's playable. Okay, and then I'll just call this render function. So update functions, we have render functions, so we'll do void render. Okay, and then we'll have void run. Okay, cool. This is like the main run function. Run. Okay. Excellent, excellent. All right, cool. So we're gonna want to use smart pointers. Smart pointers allow you to not deal with the headaches of raw pointers. Smart pointers clean up after themselves. If you don't use smart pointers, you're going to have to delete all of your raw pointers in the destructor, and it's just kind of a pain in the ass. So to avoid that, we're going to use smart pointers. So the most standard smart pointer is std unique pointer. All right, this creates the pointer. All right. Then we want to make a unique pointer of a specific class, okay, or data type, essentially. And we're going to make that SF render window, okay? And we're going to call that a window, okay? And what we're going to do in this game class is essentially copy what we have in this main function here, okay? So this game is going to run in a while loop, okay? And essentially we've created an SF render window pointer that's going to create this window, okay? And in this while loop, you're going to have you have update functions and then you have render functions, okay? But essentially, we're going to put this while loop in that run function, I believe. I'm going to do a little cheat sheet here just to make sure I'm 100% correct, because I did it the exact same way in this. So if I go into here, and I go to game, and I go to CCP. Okay, yeah, so you see my while loop is going to be in this run function, and then for the render function I'm just calling the render components of this, and then in the update function I'm calling essentially just the update components of this. And I've broken some of these updates into smaller functions that are just a little bit easier to manage. Okay, so bada boom bada bing. All right, cool. So what I'm going to do is I'm going to create an initialization function called void init window. Okay, so this is just a pointer to a window object, so I actually have to use this init window function to create an actual window object for this window pointer. All right, so I'm going to go with this window, meaning that this window variable pointer is going to be equal to std make unique render window. Okay, just like that. Okay. And now in this render window, I can add all of this stuff, okay? And we'll make this a little bit more complex at a later stage. Oops, all right, and this is going to, but I might call this, so essentially this is going to be the size of the window, so I might change this to 800 by 600, and I might call this game engine, okay? So just so you understand what's going on, we have created a smart unique pointer of a render window object. And all this is a pointer. It has nothing connected to it, all right? So to connect something to it, we have to say that it's equal to std make unique, means make a unique pointer, all right? We're making a unique pointer of the same type as this pointer. That's important. And then these are just kind of the default initializer variables of this class. So you see this is the actual class, and you go to peak definition here. This will have its own kind of constructor, all right? It has a bunch of different overloaded constructors that allow you to, you know, put different things in here, okay? But that is about all we're gonna do for now. Right, so what I'm going to do is I'm just going to create these, and I'll call these initializers. Let me just make sure it's spelled right, just so I don't look like an idiot. Yeah, just like that. Cool, it spells it right. I'm not that great at spelling. Okay, so there we go. And then in this constructor, we will call this init window function. And the point of these initialization functions is to just kind of keep your constructor nice and clean, okay? And what I'm doing here is you can just double click and you can hold Control and press period enter, left on the right side, the right period enter, and it'll create it like that. We don't need to do anything with the destructor because we're using a smart pointer. We don't need to put like delete this pointer because it's going to delete itself. That's the point of a smart pointer. Another thing you could do is you could right click, you go to quick actions, and you go create declare, and that'll do the exact same thing, okay? So I like to keep all this nice and clean in here, so I'll put that there. I'll put this here. Put my update functions here. Okay, cool. Okay, cool. So, great. So now I'll create a float and call this DT because we're going to have this literally everywhere. That stands for delta time. And then I'm going to need an clock, and I'll call this DT clock. Okay. If I go back to my game engine here, just to cheat real fast. Yeah, exactly. DT clock, restart, bam, bada boom, bada bing. It's like, yep, exactly. Cool. All right. So what this, in this update DT here, this DT is going to be equal to this DT dot DT clock dot restart as seconds. Okay, so this clock is a SFML class that essentially just starts a clock at the time of running the program. Okay. So essentially what we're doing is this is going to be equal to this restart as seconds. So whatever this is going to get that, and then it's going to restart the clock as seconds, okay? And you'll see how that's used in a second. Now we're going to go to update here, and we're going to control period enter, create that. All right, now what I'm going to do is I'm going to take okay, I'm going to take this for right now. Actually, I'll take while. That's fine. I'm just going to take this for right now. Okay, so this is a pointer, so we'll have to do this, and I'm going to add this here just to make sure that you understand that this is a window variable. You don't have to add this. Another syntax that people use for this is like like that, but I like this because it's just easy on the eyes to see that you're dealing with a member variable. That's pretty much it. It makes it a little bit easier to read, and I can also have like a parameter input called window, and if I use this, I know that I'm referring to the member variable versus the parameter input of a function. Okay? So what we're going to do is every time this update function gets called, we're going to call this update delta time. Okay? And every time delta time is called, you can do std cout. You can do this et, make a new line every time that happens, and we might do delta time, so it's really clear, just like that. Okay. Every time this update function is called, we're going to get a different delta time, and essentially what we're getting is we're getting the time it takes to do this update, okay? And that's what we're getting. Okay, now in render here, we're going to take this portion of this, and we're just going to clear. And again, we're using a pointer here, so we got to use this. Use this. Okay. Get rid of the shape. We're not using a shape here, but I could make this clear to a specific color if I like whatever I want the default background color to be. So I could be like, this is cool magenta, right? Beautiful magenta. All right. And essentially, every frame, the window's going to be cleared, and all you're going to have is this magenta background. And then stuff's going to go on in between this, and then it's going to display it. And this just happens every single frame. It's going to go through the update, and then apply some updates, and then go to render, and then render whatever those updates were to the screen. And it just does that really fast, just like an old school cartoon when you flick the pages, all right? And essentially every page is a frame, and then the drawing's slowly changing on every page, and then those are you see an actual movement when you flick through all the pages fast, right? Exact same thing is kind of going on here. Okay. Now this run function, we're going to call the update function in here. Oops, I'm sorry. Before we do that, we're going to need this entire while loop. So this is going to be where the main while loop is, okay? So while this window is open, remember, this is a window pointer, while this window is open, okay, we're going to run this update function, and we're going to run this render function, okay? Bada boom, bada bing, just like that, okay? Cool. Excelente. Right, and let me just make sure that everything is nice. Oh, if you hold control and do MO, it will close all your functions like that. Okay, great. So now I pretty much got everything that's in here into this game class. So I should be able to just do well, first of all, I have this include header. I have to add this header to it because this is an actual class that I created. So I gotta do game.h, all right? And I wanna create a game object, call this the game. That, right? And then I'm gonna do game dot run. All right? And that's all I will have in my main function. All right, so this should work. And look, I got that beautiful magenta, and you see the delta time. See, I have a really fast computer, okay? I have like a graphics card, 8 gigs of like cache RAM, and I got like, I don't know, I got like an i7. I got a really fast computer. So my delta time is extremely slow. For example, you can actually limit the frame rate in SFML. So if I were to go to this window frame rate limit, and I were to make this 15 frames per second. Now this is going to limit, and this is very good for testing. This is kind of a testing thing. You should limit your frame rate to maybe like 120 or 60 just for your game, but you can also use this to test, all right? If I were to limit this to 15 frames a second, all right, you see how much slower it is. It's like like before it was like 0.000 something, now it's like 0.06 to render 1 frame, all right? So it's much slower now. If I were to change this back to like 120, all right, now it's like 0.00 something, right? So it's like super fast now, okay? So it's rendering many frames a second, okay? So essentially, if you're moving 220 pixels per frame and you multiply it by this extremely small number, it's going to bring that 220 pixels per frame down to something more reasonable, like 8 pixels per frame. And if you're very slow, then it's gonna take that 220 and actually multiply it by a larger number to actually give you the equivalent in movement speed. All right, so that's how kind of time stamping works. You should Google timestamp and just look more into that. You may find a better description of it, but essentially it's just a multiplier. Anything that moves in the application, we're gonna multiply it by this delta time, and that's gonna make our movement frame rate independent. And if you have a really slow graphics card, it's still gonna look like crap, but at least your character's gonna be moving at the same speed as someone on a fast computer. So that's kind of the whole point of it. Okay? So it's a good place to stop, and I'll see you in the next video. All right, bye-bye.